Okay, why don't we go ahead and open up to about page 309. So, what have we learned so far? We've done mole to mole reactions and mole to mass. Okay, so we just do a little bit of practice with that. So last semester we did stoichiometry as well, but what was that called? True. That is true. It was a different type of stoichiometry. Last semester was composition stoichiometry, to where this semester is reaction. That has part to do with it. But now it's reaction stoichiometry because you have to have a balanced chemical reaction. So with that, we had just made a problem up on the board yesterday. There is a sample problem C that you could read through on page 307. But on page 308, okay, in this case, they give you the reaction and they balance it as well in those practice problems on the top. So is it one you'd like to go over, number two you'd like to go over, both of them, or what do you feel is in your best benefit or interests or whichever? Okay. So when magnesium burns in air, it combines with oxygen to form magnesium oxide according to the following equation. If you're going to be a metallurgist, or if you have any type of work to do with types of metal, if it has a lot of magnesium in it and you're trying to weld it, it's very difficult to deal with just because of, if you know anything about welding. Who was that in here? Anybody?
Not yet. We're getting there.
Okay. So what would you guess? Is it going to be, when you say stick welding, I don't think that's a very good way to look at it. I think arc welding is a better term. Or do you mainly do your, is it MIG or TIG, I think is what you call the two? Okay. Or wire welding. But what happens if you're doing that arc welding, okay, or stick, you're sending a large volume of electricity through the handle, which then has that stick on it. And when you complete that circuit with your welder, okay, that electricity gets shot through there at such a high temperature that when you have, per se, two pieces of metal that are close together like this, once you strike that, you start to melt the two together, and then that's what you mean by welding. And then once it cools off, they are now stuck together. Okay, but if one or both of these has magnesium in it, with this reaction that you see here, it's tough to deal with that because it's going to give off lots of bursts of energy because that magnesium is reacting with the oxygen because you're heating it up so fast. I think it's kind of a tough metal to deal with. But anyway, as we look at this, what is the mass in grams of magnesium oxide is produced from 2 moles of magnesium? Okay, so here they give you the equation, of course. We've got our magnesium, and is it magnesium plus oxygen, right? Yep. Okay. It's going to give you your magnesium oxide. Okay, we need to have a 2 there and then a 2 here. So we've got it balanced. So what would be the best way to proceed forward with this problem?
2 moles for magnesium.
I mean, as far as like when you did your problems in physical science, we said the best thing that you can do, you've read the problem, write down the information that you know so you don't have to keep looking back up at the story problem. But in this case, what might be the best way to proceed forward?
Write 2 over top of it.
Right. So we've got 2 moles of this substance, okay? I would suggest that you do this until you get very proficient at it, okay? And maybe it's, if you're in the gym and you're practicing shooting hoops and, oh my gosh, I've shot 12 times and I've only missed once. Like, why can't I do that in the game? You ever ask yourself that? Does that ever happen? Okay. I don't know, just good practice, I guess. But anyway, until you get really good at it, I would suggest, again, that you continue to do these problems this way. Okay. And then, again, it's asking how much magnesium oxide is produced. When we say how much, that means it's going to be in grams, so therefore we don't know. There's only one place that you can start these problems, and it's with this information right here. Is that where you want to work through it on your own, or are we working on this together? Always, I can cheat. I can just say, well, just do what the book tells you to do and get 80.6 grams. But maybe that does not help you unless we go through the process. So which do you prefer? Go through the process. All right. So if we've got 2 moles of magnesium, okay, we've got to get from the reactant side to the product side because it's asking for grams of that magnesium oxide. And in this case, this is one of the maybe few exceptions. I had the blinds. Do you like it when they're shut? Sometimes when in the wintertime, it just gets really bright in here. Just go ahead and leave. Otherwise, it's kind of dark too. Okay, I'll just leave them down. Can anyone foresee far enough? If you missed the mole ratio, is that a problem here? Other than not showing your work, but would it be a problem? Why are you right? Right. Because it's 2 over 2, okay? So when you demonstrate that, okay, we're saying we've got a pretty good foundation of knowledge on this. How do we cancel moles out in our second step? Okay, so, and you don't have to put anything here. We just know we want to get to that side of the equation or switch substances in here. And the only way to do that is with a mole ratio. Okay, so now we've canceled our moles and we're trying to convert that to what now? Grams of what though? Yeah, but we're not that far yet. Okay, so we've got to go through moles of magnesium oxide. Okay. So there again, anytime you see a mole over a mole, what must you do? Look back to the reaction and do what? Yeah, because we got 2 separate coefficients here. This 2 is coming from that one. This 2 is coming from there. Now we are on the other side of the equation. We're at our moles of magnesium oxide, and your final step would be what? How do we get rid of this mole here? Okay, so for every mole of magnesium oxide, 16 and 24, is it 40?
Yeah, 40.31.
Okay, so 40.31 grams of magnesium oxide. Okay, so these are gone. Again, don't put a 2 here. Okay, if it happens, just try to learn from that mistake. Okay, because again, if you get interrupted doing your work, you're going to say, oh, I got that 2 here. It goes down there. Remember, that only takes place when you have a mole ratio. So what you could say is that these 2 cancel each other out, like you said earlier. So 2 times 40.31, okay, 80.62 grams of magnesium oxide. Okay. All right. Hopefully somewhat straightforward. So the request was to do both of them. Is that still correct? Okay. And if you choose that, hey, I think I've got it, that's fine. Okay. You've got the textbook as a resource. People may choose to go back and look at this, but there again, that is your choice. So the second problem, what mass of glucose can be produced from a photosynthesis reaction that occurs using 10 moles of carbon dioxide? Okay, so we've got, I'm just going to go ahead and erase this top reaction because we don't need that anymore. So you learn in biology, plants take this, they absorb this through the root system, and then what's given off as a byproduct? The oxygen. But we'll put him way over here. Okay? And what are they making here? I wish we were talking about different forms of glucose because that means we're doing, but that's the senior level class. That means we're in the biochemistry, and that means we're probably in March, but we're not that far yet. Dang it. It's your fault we're talking about glucose in general chemistry. No, that's fine. Anyway, so what are our coefficients? Okay, we've got 6, then 1 and 6. Okay. All right. And if I remember, we got what, 10 moles of this? Okay. So we've got 10 mole of carbon dioxide, and we want to know how many grams of this is produced. Okay. Do you want to work on that on your own? And try it on your own, and then I'll just kind of stand up here and I'll kind of work through it. Yeah. We can do that. I'll even just hit pause here so you don't have to listen to the rest of the ding-dongs in here. Okay. Okay, so as we come back to this, there's only one place to start. We've got 10 moles of carbon dioxide. Okay? We're on the reactant side. We have to get to the product side. Okay? So in order to do that, we have to go through the mole ratio. So how do we cancel out our moles of carbon dioxide in our second step? Okay? We're going to put that on the bottom. And even when you do get better at this, you can probably do 2 things at once. Okay? But, and what I mean is you can go ahead and start when you get really good with these problems. There's really no rhyme or reason why you can't. Okay? Oh, we're not dealing with oxygen. Maybe we're getting a little ahead of ourselves. Whoops. I did that to see if you're paying attention. Yeah. And it worked. Do we believe that? I wouldn't either. All right. So then in our last step, we're over on the right side. Our moles of carbon dioxide are gone. We are in moles of glucose, and we cancel that out. How? Okay. So for every mole of glucose, we've been doing this, it's what, 180 something? Yeah. You sometimes get these numbers memorized. 180 point what? Okay. And that's grams of glucose. And then when you show your work like this, when you have this label in gram of glucose, now we've got grams of glucose up here, so you know that you're done with the problem. Okay. So 10 times 180.18 divided by 6, 300.3. Okay? Just what we were looking for. And that is grams of glucose. Now, You might be asking yourself when they're going through some of these sample problems, one of the aspects that you may have to sort out once you get to college is something called significant figures, okay? This gives you a fairly precise answer, but what we typically like to do, going out to the nearest hundredth, okay? To me, that gives you more of what we call a more realistic answer, I think, because otherwise when you're talking about significant figures, okay, is it going down that road do you think might confuse you? Should we stop here with talking about significant figures, or do you just want to hear what it is and say, gosh, I'm glad we're not doing that? Okay, what that means is this has five significant figures. This one's got one. Zeros are not significant unless they're between two significant figures, or if it's the last one, or if there's a decimal point. That's what we mean by it gets to be really, really confusing. And what you may have to sort out, okay, for those of you taking this in college, 1 year from now. Don't know? Do you think you're going to have this in your future? Well, but that's awesome that you're in here, though. Everyone else is, we're happy that you're here, though. Okay? Mm-hmm. Did you say wink? Oh, leave. I thought he said, man, you're pretty good at ventriloquism there or something. Just like this morning, I was in the gym. I could have swore Mr. Husby said, rotate. That's why I looked at you two. I said, what are you putting your basketballs away for? I told you to rotate. What was what? Change? Go change. Okay. Anyway, that's what we mean by significant figures. So, hey, we're talking about sharks now in zoology. Doesn't that sound like fun?
Yeah.
Mm-hmm. Do you know what, in mafia terms, do you know who or what a loan shark is?
Someone who gives out money with an interest.
Yeah. If you take a $300 loan out from a bank, you don't pay $300 back. You might pay $315 because that 15 is compiled in interest. You take a $300 loan out from a loan shark, and you're maybe paying back maybe 550 total. Nah, not that much. Maybe 400, maybe, because loan sharks, their interest rate is just so much higher. That's why great whites are so rich, because they're loan sharks. Yeah. Loan sharks. See, I can really punish you now. Baby shark, do 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 do. Baby shark, do 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 do. Then I don't know, Mama, and what's this grandpa way up here? Does he have his teeth anymore? I don't know. Probably not. Okay, we will do some mass to mole problems tomorrow, and then I don't think we're going to have any assignments this week. We'll save that fun for next week. All right, providing no questions, we'll catch up to you next time.